Hi guys, welcome to a new Nyjo FX tutorial. We are still working on the project about moving data from LiquiGen to Unreal. So in this new part, this is the second tutorial, we are going to create the scene inside Unreal, and then we are going to convert the data from LiquiGen using Houdini. And we are going to use three ways. We are talking about instancing the particles, using the VDB, and using the JSON data to control the Niagara particles. So let's create a new project, and let's say LiquiGen. Let's say we go for a blank. So LiquiGen Unreal Part 2. It's too long, so let's do something like that. Okay, it's creating the project. Then the idea is to import the fluid, because we'll have the possibility to have the fluid inside Unreal in a really simple way because we have the cache. Actually, we are doing nothing to the Alembic cache for the fluid, but if you like, you can take care about the mesh using Houdini or Blender or any other software like 3ds Max, Mario, etc., to have a better meshing. JangaFX is working on a new meshing algorithm for LiquiGen, so it's something you can see on the roadmap for the future builds we are going to use in a few months and weeks. So, right mouse button, let's create a new folder, and we can call it LiquiGen Caches. Inside LiquiGen Caches, we go to have a new folder, let's say fluid mesh, and the second one will be foam. And inside foam, we are going to have different ways to use it. By the way, the first thing, we can directly drag and drop the cache here. So we have just to go in the folder, Waves Unreal, and we're going to pick the one that is optimized, because you know, the others are really big and it takes a lot of time. So if you like, you can use the one that is not optimized, so all the polygons, but it's something around 24 gigabytes. So the process is the same, but it will take more time to be imported. So let's go to drag and drop here, this one. And here you see that we have the Alembic cache import. We have to say that we are going to use a geometry cache, so it's animated. You see that we have just 80 frames because it's a test path, and the other way you have all the frames. No problem about the flattened tracks because we have just one material. And for the other stuff, for the moment, let's leave everything by default. So import, and then it starts to import the frames. So it takes a little bit of time because it needs to import everything. In the meantime, we can go inside Houdini to do the same thing. So we go inside Houdini and we start preparing the scene. So let's press the P to have the parameters. By the way, tab, and let's create a geometry node. And this one is the fluid mesh. So we're going to do the same stuff, and then another geometry, and here we'll have the foam particles. First one, let's go to use the tab Alembic, and with this node we are going to load the Alembic cache. So let's say load fluid mesh. We can choose from here the cache we like to load. So we go here, and let's use the same, the optimized. Okay, we have it, space F in the view, and then you see that we have the cache. And it works perfectly. Okay, so we don't need anything here because we have to do nothing to our cache. It's just for purpose to see. So just to have a connection, let's create a null, connect. And this one is the out fluid mesh. And this one is useful just to pick the stuff when needed. Then on the other side, we need to have also the particles. So we do the same. Let's create an alembic, and let's call it load foam particles. And then we go to pick the foam, and we are talking about the foam ABC, if I remember. It should be the right one. So let's wait, and in the meantime, let's go for a moment here. Okay, you see that we have the stuff imported. So to have the project moving forward, we can pick the liquid mesh and move it here. Scaling is really low, so I think we can scale it. Let's say that we stay at 0, 0, and let's say 100, 100, or maybe we can go for 100. Yep, that's okay. But if you like, we can also go for 10, 10, and 10. Okay. Later we can tweak the scaling as we prefer. It's not a problem. Okay, so we have our water mesh inside the scene, and obviously, actually, we can do anything because it's not animated. So let's go to create a folder. Let's call it assets, and we move the liquid mesh inside. So we have the stuff inside here, and then we can create another folder for light rig. So we are going to create the light here, etc., etc. So we have to add a level sequence. We can use the default naming, it's not a problem. So now we have the sequence, but you see that we have no animation because we have to add the object. So what we have to do is to add the liquid scaled, but again we have no animation because we have to say which is the animated tracks. So click over track and then choose geometry cache, and then you see that it's moving. So we have the fluid moving inside our scene. Another thing we can do is to prepare a material, and let's say that we go here, new folder, and let's call it materials. We are not going to create distances materials and stuff like that. We are going to create something really simple. So let's call it water fluid. Okay. Then back over the mesh, and here we can directly drag and drop this material over there. Okay, so we have the material right in the right place. Let's double check here if we have the particles. I think yes. We have to double check. There is something that is slow down the particles. We'll take care about it in a few seconds. And it's essentially because I think we are using the wrong one. So the one we have to use is this one. So now it's okay. Now it is working. Sorry about it. There was a problem because we were using the wrong one. So now you see that we have the particles and we have the mesh. So everything is working fine here inside Houdini. So we have to move forward and play with Unreal to take care about the simple shader for the water, and then we move forward with the particles here. So let's go to create a new material. We're going to do something really simple. So let's say this one is called water fluid, and we can go to assign this one here. And about the material, let's say that this one is, let's go for something like that. Okay, the roughness is, let's maybe just a little bit. Okay, you see that we have the reflectivity. Let's go for something darker. So we have essentially a darker material, and then we can see if that's enough. I'm not going to create something that is so precise, you know, it is just to make something simple. So for the moment we are going just to create something that is really simple, so don't worry about it. Okay, and let's go maybe lower with the roughness. Okay, I like just to have something like that, and then in the next part we are going to create something more complex. So this basic material is here, and we are able to import the particles, but we have to find a way. So first of all, let's save everything. You can use the Ctrl+Shift+S. So let's go back here, and we have to play with the particles. So the problem generally is that you can load the ABC points directly inside Unreal. So what we can do is to move everything in a different way. So the first way can be, for example, creating instancing. The other way can be creating the VDB, and the other is the JSON. So first of all, let's add an unpack node. In this way, I like to show you. In this way, we are splitting the view here, and then we go to seeing the inspector, the geometry. If we select this one, you see that we have just one coordinates, and that's the main coordinates for the phone. So it is not the right way, because we need to access to all points we have inside. If we go to unpack and we set it visible, you see that now we have all the data information we have actually inside the points, and we are talking about the position for the 3-axis, the age, the ID, and the velocity for the 3-axis here. So we don't care actually about the other stuff, so the only thing we need is to use the unpack. So then we have 3 ways. Let's say that we have 3 node point. The first one is instancing. And from instancing we have 2 ways. Let's say null. Let's say meshes. Another null. Let's say VDB meshes. And that's a way. And the other way is to create directly, let's copy this one, Ctrl+C, Ctrl+V, and this one is the VDB. And the last one, copy, is the JSON Niagara. Okay, 3 ways to do the same thing. If you click with over the keyboard Shift+S, you have the connection made with the curve. So that's the main idea, playing with the particles in this way and create 3 different ways to manage the data. So let's move the stuff here and then continue working in this way. We have a lot of particles. So if we go here, you see that we have 3 median particles. If we are trying to do the instancing, this way will be really, really slow. So we have to decide to move in this way just an amount of particles that is possible to move to Unreal. So one way is to choose maybe a percentage of particles and instance and create the instances just for this part. So we can create a group. So group create, and here with the C we can change the color, so we know that we have some colors, and this one is the green, and here we have another green, so we know that we have 2 different ways for the instancing, and the VDB is another color, and the JSON is another color. So we have something that is more clear. So select particles, that's the name. So about the group, we can go for the keep random chains, enable, and say that we like to have, for example, just 1% of particles. Okay, if you like, you can create here a null. We go for the Z key to change the icon, and then the C about the color, and let's say parameters. So we can collect parameters here, and the first one we can have is essentially the percentage. Okay, so then we can go here, edit parameters, and say we need an integer, and let's say instance particles percentage. Range for this parameter is 100. Accept. The false value is 1, and then we can say right mouse button, copy parameters, and then we go here and say pass relative. So actually this parameter is controlled by this one. Okay, so this group is done. Let's give a name to this one. Let's call it to be removed. Then we can add a blast. The blast is essentially not to remove, to erase stuff. So let's say remove foam particles. And obviously we have to say which are the particles. Let's say that the group is to be removed, and say to remove the not selected, delete not selected. So actually we are going to, there is something that we have to, we are talking about points, obviously. The group type is a point, and then if you go here, now you see that we have a lower amount of particles. So just some particles are inside our scene. Okay. Now you can do the instancing. You can have two ways. So we can split again the process. One is the VDB from particles. For example, obviously there are many ways to do the stuff. By the way, one can be doing, let's say, create VDB points, and if we go here, you see that we have really big points. Obviously that's too big, and here we can have another parameter, and this one is float, and let's say that this one is the instance VDB voxel size, range 0.001 to 0.1, for example. The false value is 0.1, just for example. Copy right before, and then we go here, paste relative. And we need also the point radius. This one is float 2. You see that in this way we can scale the particles. So another parameter, and this one also is float, and this one is instance VDB point scale. Let's say again 0.001 to 0.1. The false value, let's say 0. Oh, let's see which is the default here. Let's say 0.5. Okay, and then copy back here, paste relative. Okay, everything is connected. So now, now if you go here, you can see and scale this value. That's wrong because it's 0.1 is too much. So edit parameters, and this one, the maximum is 1. Okay, so if we scale, you see that we have the particles. By the way, if we go lower, we need obviously to have a voxel size that is smaller than the particles to have something that is more precise. You see that we have still to go lower, and then you can scale it. By the way, let's go to save this project, and let's say we go in the folder where we have the stuff, and let's say font converter. Let's give also an underscore. So when you have the VDB data there, you have to use a convert node to convert everything to poly. So let's call this one to poly. And then you see that it's going to create the particles in a polygon way. If you like to have something that is lower about the polygons amount, you can have a poly reduce, and here you see actually it is set to 100%, but we can remove it. Let's say that we go here, edit parameters, and we go for a label message here, and we say that this one is instance VDB particles meshes params. Okay, and then we go to have an integer, and let's say poly reduce percentage, and range is 100. Okay, let's say 50, it's the default value. I didn't see the message here. Let's double check what's going on. Okay. Instance VDB particles params. Okay. Accept. Okay, now we have it. Copy parameters, and then here paste relative. Now it's optimizing. You see that it's moving forward, creating an optimized version of our meshes. So you see now you have less polygons. It takes a little bit to be calculated, but that's a way. Okay, so let's say optimize polys, and then the last one, you can cook everything with a raw alembic. Connect this one and say save VDB particles. Let's call it in this way. Okay, and here you can have the name. Let's say form VDB instance particles. Okay, that's the name, and obviously we go for a frame range, right mouse button, delete channel, and say 80 frames. That's the maximum. Control S to save. Okay, so let's move forward here. We need a separator, and then we can move forward with the other stuff. So you see that here we have the parameters for this area, and then we have the possibility to move forward with the others. So let's say that that's okay. We can create a group later. By the way, let's say that this one is a group, and here, sorry, and here this one is the group particles, and here we have another group. If you like, you can change also the color. Sorry, you have to select this one, and this one is the VDB particles. Okay, so that's something. So we can essentially go and save this one. So if you like, you have just to click over save to disk, and then it starts. Okay, it will take a little bit to create everything, to give us the possibility to have a mesh that is simpler than the previous one. So the saving process is done. I like to double check how much is actually, that's the VDB instance. So is this one, you see actually it's 1 GB and 4. We can try to import this one, and let's say that we have a new folder, and this one is the VDB instances. Okay, and here we do the same thing we done before. We go to import this one, geometry cache, everything is okay. We go for the same scaling, and then we double check everything. So you see it is going to import as we done before. It will take a little bit, not so much. If you have something more complex, obviously the process about importing will be slower. So let's go back for a moment inside Houdini. The other ways, if you like to have generally directly the particles export, you have to create the geometry for the particles. This way maybe it's a little bit less optimized. Obviously, again, we are working on something to be used real time during the recording. Remember that we have the possibility to have more particles. By the way, let's say that we go to create an instance. So we need a mesh, and this mesh is essentially the mesh for our 30 particles. So let's go to the minimum amount of face we can have, and this one is the foam particle mesh. This one will be used to create the instance. So let's go to we can use the scale directly here. So we can use something here, and let's go to edit the parameters. We go for a new labeled message, and here we say that this one is the mesh instancing. Okay, and then we have a float, and this one is single particle mesh scale. About the range, let's go for 0.0001 to maybe 1. Let's say accept. So we have this one. Let's say for a moment we have 1. And about the instancing, now we can copy this one, and then here paste relative and Ctrl S. Then we need a copy to points, and we say directly to use the packed instance to be faster and to use less memory. So we need the particles, and that's the particles, and we need the mesh to be instanced, and that's the mesh. Okay, if you like, obviously we can have also the parameters for the single particles, I mean the rows and the columns. So maybe we can say let's add an integer. So let's say mesh rows, and we go for 3 to 10 maybe maximum, and then another integer is the mesh columns, and we say the same 3 maximum 10. Let's set to 3 and 3. Okay, copy, and then here paste relative, and then copy and paste relative. So everything is controlled here, you know. So about the scaling, obviously the particles are too big, and let's say that we go to scale it down. So you see that we are controlling the scaling directly here, and we can go smaller to something like that. Okay. Same thing we done before. We need a new save. So let's say we have a new node here, and this one is the save instances. Okay, and let's say that this one is the foam instance particles. This group, let's change the color to something that is more readable, and let's take instancing. Okay, Control S, and then if you like, you can have also the optimize, but you can optimize directly using a lower amount of polygons over the single particle mesh. So let's go to export this one to save to disk, and then it is going to save. So this one is saved. We have something. Okay, obviously we have a problem related to the particles. By the way, it's not a problem for the moment. Let's go back here. So we have the first one, that's the foam. Let's move it inside assets. We use 0, 0, 20 and then 10. So let's say 0, 0, 20, and then we add 10 times scaling 10 times. So we have the right one. Okay, so you see that we have the particles. Obviously we have not so much particles for the moment. We are talking about let's double check how many particles, just to know. We are talking about 30,000 particles, so it's a low amount. Obviously you can do something better. You have just to say that you like to have more particles. Let's go back here and we can prepare a material. Oh, sorry, not a folder. Yes, delete. Let's prepare a material, just a temp material for foam. And then let's select the foam and assign this one. And then we can go here. We can do something, let's say, maybe just for a moment we can go for something like that. So a subsurface material with a white color, nothing special. I'm not taking care about the look for the moment. So you see that that's what we have. In the sequencer, obviously we have to add the foam because we have no foam. Let's say foam, and we have to do the same, selecting the geometry cache. And now everything is moving together. So this one is a way. Obviously, what I can say is that in this case, you should create something that is lower scaled about the particles. So I mean, let's say that first of all, Ctrl Shift S, and we save everything. For example, in this case, I would do something like that, and it will be having more particle. Let's say, for example, 3% or 5% particles, and you see that the amount is higher. And then checking the VDB here, the particles are really big. So I would say maybe the voxel size, let's go a little bit lower. Let's scale down the particles. Let's go lower with the VDB voxel size. Let's go lower with the particles, but they are still big. So let's say 0.05 and then 0.01. So the particles now are smaller. Let's try to go just a little bit lower with the scale. Let's see how much we can scale down the particles. Yep, maybe something like that can be something we can work with. The poly reduce, that's okay. Obviously we have more particles, so if needed you can have an higher poly reduce, and then you can go to export this one again. Let's say we call it high, and Ctrl S, and we can export again just to see the difference between this one and the other one. So we'll have more particles, 5 times more particles with a smaller scale, to see if we have a better quality. Again, if you like, you can also use the instance. This one is slower, I have to say. It's really slower, but you can use it. And to import this one, we should have a new folder, and let's call it instances. And in this one, you can go and pick the instances. And I mean, we are talking about the foam instance, this one. The other problem is that this one is a lower quality than the other. So for the moment, let's wait to import the high quality. And in the meantime, I like to show you something else, and is related to create a foam particle. A really simple setup for the moment. I don't want to create something that is complex. So let's, okay. So we are talking, okay, this one, we don't need it because we are going directly with this one. So let's talk about the VDB. What we can do about the VDB? We can have another layer, level of particles we are going to select. So we can copy this one and paste here and call this one VDB, and this one too is named VDB. So the group can be called VDB, and then when we go to change this one, is obviously we do it in a few. So let's use the underscore every time. So if sometimes I'm losing the underscore, don't worry about it. Then let's say delete channel, and we need another parameter. So that's the mismatch instancing. Then we need another parameter. Let's say that we have another separator here, and we have a message, label message here, and we say that this one is the VDB params. Okay. So the idea is that here we are going to create the parameters for the VDB. So we need for sure the amount, so the percentage, and we need for sure the VDB scale and stuff like that. So let's go here and let's say that we go to create something like this one. So we need an integer, and this one is the foam particles percentage. We go for 1 and 100% and accept. Okay, let's say 1 is the default. Let's say copy parameter, and here paste relative. Okay, so let's do the same thing we done before. We have just to say that this one is the one that needs to be deleted. About the parameters, if here we say 10%, you see that we have more particles. So let's say that we like to see just the foam, and Ctrl S. So now we can do the same thing. So we are going to create the VDB from particles. Okay, and we need again the particle radius and the voxel size. So we need the same thing we used before. So we go for to have two float value. One is the VDB voxel size 0.001, and let's say 1, and then another float, let's say VDB particle size, and again 0.0001 and 1, and then we can tweak it later, it's not a problem. So here we have 0, 1 and 1, so let's say that we have 0.1 and 1. So this one is copy, and then paste relative, and then this one is copy and paste relative, convert to VDB. Okay, so let's start playing with the stuff. We can have also maybe a VDB smooth. Okay, you see that this one is going to smooth everything. We have different ways to do it. We have also the Gaussian that maybe in this case is not bad. So we have just to decide, let's say maybe, let's see with a really, with 4 for the moment, and then we'll double check later. So back here, we need to have the particle size lower, and this one needs to be lower for sure. Okay, and obviously this one is lower because we are using more particles, and the voxel size is really precise at the moment. Let's wait for the update. So let's say that we go lower, but I like to have, okay, let's go lower. Let's see with a VDBs move what we have. Okay, it's not able for the moment to work on this one. Well, we need an higher quality for sure. So let's say that we go. Let's use a higher number of particles because it's better to have more particles, as you can see. Okay. And let's say that we go to 0.001, so it takes a little bit, and then let's go to smaller particles. Okay, let's say that we are using all particles 100%, and we need smaller particles for sure. So let's say the voxel size is 0.005. We are going smaller and smaller. Obviously, you can create something more complex to move the data around. I'm creating a simple setup just to give you an idea about how we can move forward with a particle from LiquiGen to Unreal. Let's wait. Okay. This one seems not bad. You see the volume is really nice. So in this case we have something like that. If we like, obviously, again, that's not the best way to do it, because using the VDB you can create something that is more uniform about the mesh, but it is slow to be processed. By the way, you can do something like, for example, using VDB reshape, and in this case we can, for example, delete the VDB data. Let's say, for example, maybe 3 can be enough. We go to connect this one. Let's set update to update. It will take a little bit, so we can go in Unreal to make a test and say that now we like to I think we lose something inside this one because it's smaller than the other. By the way, let's try geometry cache. Okay, it crashed. So that's the problem. By the way, we can use 2 frames just to see the quality. Okay, that's not a problem. Say yes, import. Obviously it will be really fast. It takes nothing, I think, because it's really really simple. We have more and more particles, so you saw that the cache is smaller because we have just 2 frames. So if you are going to use a higher amount of particles, obviously the cache will be really really big. By the way, let's go back inside Houdini. So we have it. This one is with the delete. Let's go back to manual, connect here, and in the VDBs move we can try in this way and say out update. Now it takes a little bit to smooth everything, so we can, for example, lose some small particles, having something that is smoother, but the problem is that obviously we are losing quality because you know, it's something like a lower quality fluid mesh. And I prefer the way using the particles. By the way, you have the possibility to choose between both. So it's updating the viewport. The VDB data is generated, so it takes a little bit. You see that it's starting to merge the stuff together. Obviously, if we go distant, it is not bad. It is not bad, but it needs some more love. So I think, for example, that we have to smooth everything a little bit more. Maybe I try with 2 for the radius, but maybe we can completely lose partially the foam. So every time that you are going to use this way, you have to take care about every single parameters. And you see it's not so fast to work with a VDB, obviously, because we have a really high quality VDB data, because we have a lot of particles and we have to try to have a really high quality mesh. By the way, remember that the next step, when you have this one, you have to convert again to polygons, and then you have to save. So the process is similar. It is just a different way, because in this case we are trying to create VDB particles. That is a really fast way without the need to use the instance. And in the other case, we are trying to merge everything together. So let's see. We have something. You see, it is starting to work, but maybe we can also play a little bit more with the offset here, and then with the VDB smooth, and maybe, but that's just an idea. Let's go back to another reshape, and this one can be set to erode, and we try to erode a little bit everything. So let's say set to manual, connect, set activate this one, and then out update, and let's see what's going on. Okay, you see we done something, because now we created the erosion, so we have something that is more similar to the foam. So that's something you can do, and again, we can play more with VDB reshaping and stuff like that to achieve something that is higher quality. By the way, I like just to show you something that can be done. And then we need again to convert everything to polygons. So sorry, I lost something because there was a crash. So here we had a VDB smooth, so I like to recreate what we done before. So we had the sorry, not this one, the VDB reshape. And again, you can do it in many ways, so don't worry about what we are achieving here, because there are many ways to do it. And I like, maybe in the course we are preparing the LiquiGen Inception, create a new setup to give you a nice UI to convert everything automatically with the best quality possible. And then we add a new reshape here. Oh, sorry. Y-axis to delete it. And it was an erode with the default value. And about the parameters here, yeah, it was like that. And here you have to convert. To go back to poly. And then you have again a raw alembic. And this one is the VDB. So this one will be named form VDB. I'm going to call it new because I had the previous setup for it. So this one is a new group. And about the color, let's select this one and let's go for something like that. VDB form. Okay, so we have it for the moment. Obviously, we can do something more precise. We can do something more detailed and stuff like that. By the way, that's an initial view about how we can move stuff from Houdini to Unreal to convert the data from LiquiGen. And then in the next part, we are going to talk about the JSON file format. So we are going to create particles to drive directly the particles in Niagara. By the way, I like to export again this one because we had a problem before. And I'm talking about the particles. This one is the right one. So let's try to save again because before it crashed. So we can see maybe how it works, this one. And then we are ready to have everything. So you see the process this time is a little bit slow because we have the optimized that it takes time to be calculated. By the way, it will continue to save everything, and in part 3 we'll double check this cache to see how much is better than the previous one, and then we'll move forward, maybe trying to load also the other one, the VDB, and then we'll see how to use the JSON data to control any other particles directly inside Unreal. So that's all for today, and we'll talk more about LiquiGen and Unreal in a few days. Bye guys!